Today's lesson is determinants. This is from lesson 9 classwork. A few lessons ago we talked about system of equations, and determinants was one way of solving systems. So we're going to talk about determinants. Number 7, they've already set this determinant up. Your first column is 0, -3, 2. Your second column is 1, 5, -5, -3, 2, and 3. Normally you have to set the determinant up yourself. To get the values for the first column, this is usually your x value. The second column usually represents your y values, and the third column usually represents your z values in your equations. To actually evaluate the determinant, you always rewrite your first two columns, which in this case would be 0, -3, 2, and the second column 1, 5, -5. One of the skills that you're supposed to develop from a math class is organization and neatness. And if you're not neat and organized on these, you're going to have a hard time. So be nice and neat and make sure everything's lined up correctly. Now, determinants are not difficult. They will take up a lot of space, but they use your four basic operations: addition, subtraction, multiplication, and division. We start off at the top of the first column and go diagonally sideways down to the bottom of the third column. If you have written this nice and neat, like when you do that, you should go through 0, 5, and 3. Since we're at an angle, you multiply these numbers. 0 times 5 times 3 is 0. You want to do that again. You start at the top of the second column and go down diagonally. You should go through 1, 2, and 2, multiplying along the way. 1 times 2 times 2 is +4. And one more time. -3 times -3 times -5 would be a -45. Then what you want to do is take the bottom three numbers, and since they are across from each other or on top of each other, you add them. So 0 plus 4 plus -45 would be a -41. This is what we call the bottom number. Since that is the bottom number, that implies that there is a top number. To get the top number, you do the same thing except you start at the bottom and you go diagonally up, multiplying along the way. You should go through 2, 5, and -3. 2 times 5 times -3 would be -30. Again, -5 times 2 times 0 would be 0. And 3 times -3 times 1 would be -9. Add those up. -30 plus -39 would be -30 plus -9 would be -39. That would be the top number. Now to actually get the whole value of the determinant, it's the bottom minus the top. Be careful because it does involve subtraction, and we tend to get in trouble with subtracting negatives, so be careful. Our bottom number is -41 minus, because that's the rule, the top number, which is -39. So make sure you have the minus from the formula and the negative from your negative number. Of course, -41 minus -39 is actually -41 plus 39, so our answer is -2. So our determinant would be negative 2. Remember a long time ago they didn't have anything else to do and somebody came up with this. But it makes it nicer than trying to do substitution and elimination and all the other complicated things that go along with solving multiple variable systems. All right, number 8. Let's actually work a real problem. X minus y minus z equals 2. X plus y plus z equals 2. And negative x minus y plus z equals negative 4. This is usually what we use determinants for. I recommend that you go back through and any variable that doesn't have a coefficient in front of it to put that there. So this would be a 1x, a negative 1y, a negative 1z, 1x, 1y, 1z, negative 1, positive 1. Especially if you make your 2's and your z's look alike like I do. I put a line through the z to kind of keep them straight. Now, in order to solve a system, we need to find x, we need to find y, and we need to find z. The nice thing about using determinants is that one variable doesn't depend on the answer for the other. You can get x without knowing what y is. You can get z without knowing what x or y is. So you can just kind of do one variable at a time. Of course, we're creatures of habit and we tend to go in alphabetical order. So I'm going to find x first. To find x, we need two things. We need the determinant of x, and that is d sub x, not d times x, over the determinant of the whole thing. The determinant of x and the determinant of d are not the same thing. They're two different values. D sub x over d equal. Now, you can find dx first or you can find d first. Usually we find d first. To find d, the determinant, the first column represents your x, second column represents your y, third column represents your z. So in the x column, we're going to have 1, 1, negative 1. You get those values from the given equations that they give you. The y column will be your y values, negative 1, positive 1, negative 1. Whoops. Negative 1, 1, negative 1. A third column represents your z's, which would be negative 1, positive 1, and positive 1. The 2, and the negative 4, we will use that later. You do not use the equal numbers when you're doing D. Now that we've set up our determinant, we're going to work it out just like we did number 7. You rewrite your first two columns, which in this case is 1, 1, negative 1, negative 1, 1, and negative 1. You then start at the top and multiply your diagonals. Remember, if you go at an angle, you multiply. 1 times 1 times 1 is 1. Multiply again. Negative 1 times negative 1 would be 1. And negative 1 times negative 1 would be positive 1 again. Then you add those up. 1 plus 1 plus 1 would be 3. And this is our bottom number. We now multiply going up. Negative 1 times negative 1 is positive 1. Negative 1 times 1 is negative 1. And 1 times negative 1 is negative 1. Add those up. And this is your top number. It's real easy to make a mistake, so be super careful with your signs. One little sign mistake will cause you to miss the whole problem. To actually get the value of D, it's the bottom minus the top. Our bottom number is 3 minus our top number, which is -1. 3 minus -1 is 3 plus 1, which is 4. 4 is our D. That is not X. D is our denominator. So we have found the denominator of X. We now need to find the numerator, the determinant of X. To find the determinant of X, it's very similar to finding the original determinant. First column's X, second column Y, third column Z. But what we're going to do is change one of the columns. The sub number that we have, or the sub letter that we have here, is dx. That means we're going to change the x column. We're going to replace that column with what I call the equal numbers. Remember I told you a while ago we didn't use these? We're now going to use the 2, 2, -4. That goes into the first column. The y column stays y, which was -1, 1, -1. Z stays Z. If you don't change one of the columns, then you end up with the same answer over and over and over again. So to change from D to dx, you replace the x column with the equal numbers. From there, you do the same thing to evaluate it. You rewrite your first two columns, which in this case is 2, 2, -4, -1, 1, and -1. We now do the same operation. We multiply diagonally. 2 times 1 times 1 is 2. -1 times 1 times -4 would be +4. -1 times 2 times -1 would be 2. Add those up, and that is your bottom number. Multiply diagonally up. -4 times 1 times -1 would be a +4. -1 times 1 times 2 would be -2. 1 times 2 times -1 would be -2. Add those up. That is the top number. To get the value of the determinant of x, or dx, it's the bottom minus the top. Our bottom number is 8 minus our top number, which is 0. 8 minus 0 is 8. So the determinant of x is 8. We're going to substitute that into our x equal equation. The determinant of x is 8. The determinant is 4. So to actually find x, you do 8 divided by 4, which is 2. So we now know that x is 2. However, we also need to know what y is, and we need to know what z is. To find y, or you could find z next, it doesn't matter the order. I just tend to go alphabetically in order. To find y, you use the determinant of y, and again that's d sub y, not d times y, over the determinant of the whole thing. The nice thing about finding y, if you've already found x, is you already know what your denominator is. We know that the determinant is 4, so the determinant here is also 4. So we've already found that D is 4, so that information we can go ahead and fill in. The only new information we need to find is D sub y, the determinant of y. To find the determinant of y, it's very similar to finding the determinant of x. First column's x, second column y, third column z. But what's different is that our y column is the column that we're going to change. The y column is we're going to use the equal numbers, which were the 2, 2, and -4. So we're going to replace the y column with 2, 2, -4. The x column goes back to being x, 1, 1, and -1. And z column stays z, which was -1, 1, and 1. Then to evaluate it, just like we did the previous determinants, you rewrite your first two columns, which in this case are 1, 1, -1, 2, 2, and -4. Multiply diagonally down. 1 times 2 times 1. 2 times 1 times -2. -1 times 1 times -4. Add those up. That is the bottom number. Multiply diagonally up. -1 times 2 times -1. -4 times 1 times 1. 1 times 1 times 2. Add those up. That is your top number. To actually get the value of the determinant of y, it is the bottom minus the top. Be careful here. It's 4 minus -4, which is 4 plus 4, which is actually 8. Therefore, the determinant of y is 8. We go back to y equals dy over d. We now know that dy is, was it 8 again? 8. And to find the value of y is 8 divided by 4, which is 2. I don't remember both of those coming out to be the same thing. Then finally, we need to find z. There are several ways to find z. If you want to, you can do the determinant of z and divide it by your determinant of the whole thing. However, usually at this point, we have run out of room. The easiest way to find z is to use substitution. You can either use your type equation. You can either use this equation, the middle one, or the bottom one. I always go with the less negative, so I'm going to go with this middle one, which is x plus y plus z equals 2. I'm going to substitute. We know x is 2, so we're going to put 2 in for x. We also know that y is 2, so we're going to put 2 in for y. Clean it up. 2 plus 2 is 4. Letters left, numbers right. Subtract 4 from both sides. And we get z to be -2. That means the answer, instead of writing it as an ordered pair, we write it as an ordered triplet, which means x comes first, which is 2, followed by y, which is 2, followed by z, which is -2. And I just really don't think that that is right. 2 plus 2 is 4, but it checks. That makes that, and -2, -2, and +2. That would work. So the actual answer to the problem is 2, 2, -2. One more, we'll do number 9. You could use substitution and elimination to work this whole problem, but it kind of gives me a headache because you got to substitute this and resubstitute and eliminate and re-eliminate. To me, it's just much easier to add, subtract, multiply, and divide. So I prefer this method better. X minus 2y minus z equals 4. X plus 3y minus 2z equals negative 2. X plus y plus 3z equals 5. Put ones where they don't have numbers. To find x, we need the determinant of x and the determinant of the whole thing. I'm going to start off by the determinant of the whole thing. Be sure you identify with D equals so that I know which determinant you're working on. The first column represents x, second column y, third column z. The x column will be 1, 1, and 1. The y column will be negative 2, 3, and 1. The z column will be negative 1, negative 2, and 3. Those numbers come from the numbers in front of your variables in your given equation. The equal numbers, the 4, negative 2, and 5, remember we won't use until we use the determinant of x. To evaluate any determinant, you rewrite your first two columns, which in this case would be 1, 1, 1, negative 2, 3, 1. You then multiply diagonally. 1 times 3 times 3 is 9. Negative 2 times negative 2 times 1 would be 4. Negative 1 times 1 times 1 would be negative 1. Add those up. 9 plus 4 minus 1 would be 12. And that is your bottom number. To get the top number, multiply up. 1 times 3 times negative 1. 1 times negative 2 times 1. 3 times 1 times negative 2. Add those up. Negative 3 plus negative 2 plus 6 would be negative 11. That is the top number. To actually get the value of D, it's the bottom minus the top, which would be 12 minus negative 11, which is 12 plus 11, which would be 23. That is your determinant. In relation to finding x, that is the denominator. In order to actually find x, we've got to find the determinant of x. To find the determinant of x, first column represents x, second column represents y, third column represents z. However, if we use that same setup as we just did, we'll get the same answer. So we've got to change something, and in this case, we're going to change our x column. In our x column, we're going to use what I call the equal numbers, which would be the 4, the negative 2, and the 5. So write 4, negative 2, 5. The y column stays the same, which is negative 2, 3, and 1. The z column also stays the same, which is negative 1, negative 2, 3. Rewrite your first two columns. 4, negative 2, 5, negative 2, 3, 1. Multiply diagonally down. 4 times 3 times 3 would be 36. Negative 2 times negative 2 times 5 would be 20. And negative 1 times negative 2 times 1 would be positive 2. Add those up. 36 plus 20 plus 2 would be 58. That's your bottom number. To get the top number, you multiply diagonally up. 5 times 3 times negative 1 would be negative 15. 1 times negative 2 times 4 would be negative 8. 3 times negative 2 times negative 2 would be 12. Add those up. Negative 15 minus 8 plus 12 would be negative 11. That would be your top number. To actually evaluate the determinant of x, it's the bottom minus the top. Our bottom number is 58 minus our top number, which is negative 11, which means 58 plus 11, which would be 69. That is our determinant of x. Go back to x equals the determinant of x over d. We now know that the determinant of x was 69. Where did I get 12 from? Our d is not 12, our d is 23. To actually get the evaluation of x, it's 69 divided by 23, which would be 3. Now we need to find y or z, whichever one you want to find next. I prefer alphabetical order. We already know that our d is 23. 12, I don't know where I got that from. Should be a 23. Now we need to find the determinant of y. To find the determinant of y, our first column is x, second column y, third column z. This time to find the determinant of y, we replace the y column with the equal numbers. The equal numbers were 4, negative 2, and 5. The x column stays x, which was 1, 1, 1. The z column stays z, which was negative 1, negative 2, 3. Rewrite your first two columns. Multiply diagonally. 1 times negative 2 times 3. 4 times negative 2 times 1. Negative 1 times 1 times 5. Add those up. And that is the bottom number. To get the top number, you multiply up. 1 times negative 2 times 2 is positive 2. 5 times negative 2 times 1 is negative 10. And 3 times 1 times 4 is positive 12. Add those up. 2 plus negative 10 plus 12 would be 4. That is our top number. To actually get the value for the determinant of y, it's the bottom minus the top. Negative 9 minus the top, which is 4. Negative 9 minus 4 would be negative 13. So the determinant of y is negative 13. And I must have done something wrong because that isn't going to work. Let's see. First column is 1, 1, 1. Second column 4, negative 2, 5. And negative 1, negative 2, 3. That would be negative 6, negative 8, negative 5. Oh, there we go. Right here, this should be a negative 5. which makes our bottom number, let's go ahead and change that. -6 plus -8 plus -5 would be -19. Now our bottom would be -19 minus our top, which is 4. -19 minus 4 is -23. So the determinant of y is actually -23, not 13. -23 divided by +23 would be -1. That only leaves z left. By this time, you're usually out of room. You could go and find the determinant of z. To do that, you would simply replace your z column with your equal numbers. Or the easiest thing to do is to come back and substitute. You can either use the top equation, the middle one, or the bottom. I'm going to go with the bottom because it has no negatives. X plus y plus 3z equals 5. We're going to substitute. X is 3, so we're going to put 3 in for x. Y is -1, so we're going to substitute -1 there. Z we don't know. Clean it up. +3 and -1 would be a 2. Letters left, numbers right. Subtract 2 from both sides. Divide by 3. And we get z to be 1. So our answer, remember, needs to be written in ordered triple form. Our x was 3. Our y was -1. And our z is 1. So our answer is 3, -1, and 1. And that is how you do determinants. To find any determinant, your first column is x, second column y, third column z. Sometimes they change up the variable and make it a, b, and c. A would be the first column, b would be the second column, and c would be the third column. To evaluate it, you rewrite the first two columns. Then you multiply diagonally down, add those three numbers to get the bottom number. Multiply diagonally up, add those together to get the top number. And then to evaluate the determinant, it's the bottom minus the top. To find the determinant of a variable, you simply replace that variable column with the equal numbers. And then usually to find the last variable, we shorten it and use a little bit of substitution. And that is how you solve determinants.